Thanks so much, Misty. All right, super excited to dive into the AB Jetty recapitalization project. Can you start by kind of giving an overview of what all went into this project?
Sure, Ted. Thank you for the opportunity to discuss about this big project that we have at the moment. And this presentation will be specifically about a false work that we did underwater and about all the steps that we done for the design and the building phase. And that's why I called it brightening marine construction with advanced design and Revit. Um, my name is Pierre-Luc Tremblay, and I'm the team leader of temporary works at Palmerville. So, AB Jetty recapitalization project. In Victoria, there's a naval base, the CFB Esquimalt, the Canadian Army. And we are actually doing a big jetty for naval ships. And I want to pick our attention specifically on the 19B, which is the bent at the end of that humongous pier, because it was a great challenge for us, and it went pretty well and was a great experience to share. 19B bent is big. It's 4 meter high by 4.1 meter the width, and the length is 26 meters. So we're talking about like 430 cubic meter of concrete, which is approximately 43 trucks of 10 cubic meter, but could be more. It could be more. And there's a lot of formwork area around it, and you can see there's openings, and it's a big bend that's over water on into permanent piles, and we have a big structure going on top. So it was a big challenge to design all the false work and the formwork to go into it. And we had another challenge was that we had a lot of party involved, because for the formwork, we had EFCO and Deep Foundation Works for the temporary piles. Well, we had Roskin and RISEC, which are the geotechs specialists. And for the false work, we were doing the design internally at Palmerville, but we were fabricating it with United Engineering, and we were reusing the girder beam system that Ruskin used to drive all the piles. So there was a lot of coordination there. And our client was the government of Canada, and the consultant was StatiCa, and we had to verify everything with them so that everything went well.
Yeah. So, Pierre-Luc, can you describe the challenges that you faced with collaborating with so many different parties and partners throughout the different stages of this project workflow? How'd you address all these challenges?
Yeah, it was a big challenge, but like always, coordination and open communication is key. We had weekly internal technical meetings that were involving like the superintendent, project managers, and everybody involved into the team to make sure that we had our heads settled all together and that we were delivering the same message. And at each point, we were presenting it to all the parties, especially for the formwork at the beginning, because we needed like the formwork to match the false work. And we were including everyone at each stage with like a 3D model or a meeting to discuss about what we thought, and like everybody was involved, and it's all part of the like having a great work planning. And one of the first thing to do in a work planning is to see what are the constraints. Well, first of all, the environmental constraints were that we were working into water. So we're doing marine work with barge and divers. In the area, there's a huge swing into the tide. You can see there that it's like 3.4 difference of head, and the buoyancy into our system was clearly affected all the way, especially since it's salt water, because it's heavier than fresh water. But at least we had still water, so we had a negligible flow. The flow wasn't moving anything around, so that was a big constraint. The next one was that is the economic one. A dollar sign is mostly driving a decision, but in this one we had to we really had to optimize the works because all the marine works cost a lot. So, and they were unavailable, so we had to optimize for sure. And one of the biggest point too is that it's the last bend, so it's a crucial milestone in the work sequence. If we have a problem there, well, it's gonna jam the end of the project and jam all the rest, all the installation of the pier. So it's a bad thing. And the other thing is that it's different. I show it quickly at the beginning, but it's eccentric and the other bends weren't. So there was a higher risk to mitigate since it was different than the other bends. And the context, the formwork and the deep foundation were designed by others. So that's one of the issues we're talking about. We had to communicate a lot. And we were reusing some false work. So we needed to inspect and validate like each structure components.
Yeah, so you mentioned it there, but the underwater conditions that presents a unique set of challenges. How did you guys discuss these challenges? And then if you can explain how 3D modeling really helped assist in overcoming these.
Yeah, for sure. Underwater works are increasingly more challenging, mostly because you can't see anything. It reduces visibility, and everything is done by hand. So you need to think always less manipulation. And divers are exposed to a higher risk just by the fact that they are underwater and they have a lifeline going up. So there's a lot of risk into this job, and yeah, there's the financial part of it that required us to plan precisely. So that's and there is all other constraints that we need to think about just before doing the design and the planning. So before I show you the design, I'll just show you what what happened into a brainstorm meeting in it, because it's crucial. So first of all, is the band stable without support since it's an eccentric? Well, the answer is no, and it was confirmed by the consulting firm. So we had to leave the structure there and dismantle it after we finished the deck on top. So we can just go from under or sideways for the dismantling. So it needed to be easy to dismantle. That was a hard one. How to manage the work in place? Well, how to minimize the work in place? Well, everything we needed to maximize the prefab for sure. That was one of it, and everything needs to be bolted because everything needs to be assembled on the water. So if you introduce welding, it's a bad idea unless you need to do it. Also, how to optimize the false work? Well, since we're reusing a drilling template, we thought we could just use it and put a soffit on top. so that we could just bolt in the FCO formwork all around. So that was a good idea because we saved a lot of formwork there, all the bottom formwork, by using modular platforms. And another thing that's so important that could have been not thought about is that for the lateral bracing of the formwork, we could have gone downwards, but the problem is you're going to expand your falsework for absolutely no reason, because you can actually brace your formwork with the A-frame system that you see at the bottom, and not without extending the falsework underneath. So everything would go upwards, and that saved a lot of steel and structure and the complexity. And that's sort of the best collaboration we had with the FCO about that. So that was great. How to avoid side conflicts to make sure that everything fits. Well, we'll need to do a dry assemble beforehand, and we'll need to survey all the piles in position before we cut the ceiling plates, which I'll show later. And we needed to avoid tie rods in the formwork, because we couldn't place the rebar cage if we would have done that, because since it's on water, we want to build big rebar cages and just drop them in, and that's the best way to do it. So that brings me to answer back, how did we manage all those conflicts, constraint questions? How do we put that in an image? Well, by using Revit, we've done a big 3D model, and that's what I'll show you there. We put it into 3D viewer, so you can actually just go online and share it to all your parties, so they can actually just look at it as if they're there. And one of the best function that I think that one of the most useful function was the first person one, because you could actually go under and see everything as if you're a diver. So that, to answer your question, Todd, that was one of the biggest help we could have, because the divers could actually go under virtually and think about, okay, will I be able to bolt that there? Would I be able to put the gap clamp? Will I have a conflict there with the ceiling plate and the actual pile? Can I go there and fit my hand? I'm not sure. Well, I'll take a measurement. So you just go there, take a measurement, and oh, okay, I have like around 1 foot-ish, a bit more. Oh yeah, I'll fit. And then you can actually go step by step, go at each pile, make sure everything fits, see that you can access the jack, and that could look like a minor detail, but the jack screw need to be on the right side. It needs to be on the exterior part. If it goes in the interior part, well, you don't have access. Do you have a conflict with the ties and the stiffeners? Does it fit on the cap seat there? So that was an amazing tool. And imagine showing that with everybody around, and everybody just looks at it and understands instantly what's happening. So
Yeah.
that was one of the big plus, let's say, that how 3D modeling can help a construction is pretty much through Autodesk Viewer and a good 3D model there. So I'll show you. So by introducing this model, I'll just show you a couple details that were invented that were designs for that falsework. Well, we had a jacking system with shear tabs and ties. Shear tabs were to take the shear loads while being able to put down the jack and open it up and close it up. Because yeah, at the end, when you pour that, you need to jack it to put it down to strip it out. Because you can't just leave it there. Well, it would be jammed. So you always need like a jacking system. On top of the temporary piles, we had cap seats, we had centered one and offset ones because yeah, construction is not perfect. It won't end up perfectly like on a drawing. All those piles had like a tolerance and we needed to fit in. That's why earlier I was saying that the ceiling plates were put afterwards and cut last minute to fit in because all the piles had a different position than on the plan, so we had to fit it all. Those ceiling ring are just around the pile. We saw it in the 3D. It's to seal. You just put a foam in between and you sealed everything up because you don't want the water to come in the formwork while you're doing the rebar works. You don't want you don't want that. Then you have gap clamps, same function, but on the side and to attach to the beams of the platform. Then you have girder clamps to attach the platform to the girders. And you have lifting eyes because we need to lift it in place. So yeah, we had a lot of fun doing that, and yeah, we used some to do the design. We used like Advanced Design and other
So
stuff.
how did you implement advanced design? How did that contribute to really increasing the efficiencies in this project?
Yeah, well, Advanced Design was a great tool for that project because yes, we saw the 3D Revit model, but with all the detailing and everything, but you don't you don't end you don't come up with that model at the beginning. You need to go by a step of, okay, do we do that or we don't, and go forward and go backwards. And it's an iterative way to do it. And with AD, well, you can actually do the model in 3D, put all the loads, put different colors for different components, show the work sequence, test the model, test and change the beams, adjust, and you have your results with a simple click. You can actually see your steel design there with some colors. Yeah, I could have bring up the numbers, but everything worked out, so it's good. The displacement, uh, where you see because there's a lot of displacement sometimes is misconceiving because it rules the model most of the time, especially for a concrete pour. When you pour concrete, you have tolerance for the deformation you'll have on the concrete, and that all, I won't say all the time, but most of the time, it designs the whole structure, and that was the case there. And yeah, with AD, you can actually put all your load combination at once, and that's incredible. That was incredible for us because with the tide table, you could actually see like there was 5 or 6 different cases that that gave extremely different results. If you have a high tide and a formwork without concrete into it, well, the formwork acts like a boat. So it wants to fly up, and that's what designed the ties. Sorry, and when you have the tide at the lowest, but you pour the concrete, you have the heaviest weight on it, and that's what designed the whole structure in gravity. And when you have all those extreme cases put in together, you can run it just once. Well, it's amazing. And we also use the EDS StatiCa to design our our connection, like the girder clamps, the lifting eye, and it suits up very well with Advanced Design because it uses the same coordination system. So you just take your loads and put them in, and you can actually see if your connection works or not. And it's a perfect tool for engineering. So afterwards, I wanted to show you the installation sequence before I show you the actual work. So that's what Revit, in Revit, you can actually like do a sequencing of step by step with the whole structure. So you just click on whatever you want and you just put some color and you show it step by step, and it's amazing because by only looking this, I think everybody understands what how it was installed. So we put it a cap seat, we then put it the header beams, and then put it the girder beams with the platform, and then after we put the platform, we slide in the ceiling plates to fit it all, and that way with just one high view on it, well, you understand what we'll do. So that's 3D is awesome. And at the end of it, well, you need to do the stamp drawing with all the detail, all the fab drawings, and that was a lot of work because we were using well, our fabricator was we did the fabrication drawing, so we needed to make sure that everything, every detail worked out perfectly, and it went superb. It went superb on site. So that all those ideas were put up in that drawing, that final drawing, and pretty proud of that work. Yeah.
That's awesome. It's a big achievement for sure. What was it like going from the design to actually building it on site?
That was the best part. When you actually see what's built on site and that everything works out, well, that was the best part. And I'll show you some pictures of the falsework that was pre-assembled on the barge. There you can see the actual bridge deck all assembled together without the formwork on top. We don't see the holes on the platform, but there were like thousands of them to fit in the formwork with bolts. So everything needed to be perfectly adjusted so you can match that tolerance of 1/8 of an inch so that the bolts could fit. So that was one of our concerns, but everything fitted pretty well. So that was great. In the middle, you can see the platform and the girder clamp that were welded on, pre-welded on the girders. And actually, we installed the platforms and then installed the girder clamps. We bolt them into the platforms, and afterwards, we welded on the structure to make sure that it was a perfect fit instead of welding the girder clamp and then trying to put the platform. So that was a great way to do it. There you can see the gap clamp with the one-sided bolt with the screw, sorry, the nut that was welded into the plate. And there you can see afterwards you see the header, the girder clamp, the girders, sorry, beams assemble with that sits on jacks and ties, and you can actually see the shear tab there. And finally, after all that, well, we needed to dry assemble the formwork on it, make sure that every hole fitted because you can't go underwater and just you can't go underwater and just see that the bolt doesn't fit. Like it's not adjustable when it's in the water. So everything needed to be well assembled. And that brings me up to a little video of our site. And at the end, you'll see our that structure being installed. I hope the sound isn't too loud.
We're good.
So that was one of the normal bent. You see a lot of guys into it, a lot of homework, a lot of force, a lot of everything. It's a huge civil work site. Oh, and just a quick pause. Sorry. There you can see the structure that we were preparing for the lift. On the plan, I showed only that we had the girders installed and then the platform, but we found an idea and we installed the platforms on top of the girders so we could install 2 girders at a time with some formwork installed on it, because everything that you can install dry costs less and saves time. So that was a great idea of the superintendent. And see the guys prepping all the works. Crane on the barge, a huge crane, by the way. So that's the first part that we put it in. And it worked out perfectly. Our superintendent was really proud. And then the other part, just a big pause. And that's the second part. And as you can see there, it's fitted perfectly between the cap of the pile there. And that was one of our concerns, but since we planned it, we had the 3D model, we were very confident, and then it went like a charm on site. And then you can see the structure underwater.
That's awesome. Very cool.
Yeah, thanks. And finally, I'll just show you some final picture about that gives you an idea of what it looked like inside the formwork, fully installed for all the rebar works, all the prep. It's like having an army going in and working nonstop to fit everything in. Finally, you can see the exterior of you remember that big structure we saw? Well, it's underwater somewhere there, and you have the formwork on top. And we were pouring it last month, and now everything went well, and we are starting the dismantling. It should be done soon. So I'm pretty proud of that, and I thank you all for taking the time to listen to me to that story.
Awesome. Well, thanks so much, Pierre-Luc, for going through that. We're going to open it up to questions right now from the audience.